Now let's take a look at the last problem. We have AE bisecting angle BAC, which means that this is an angle bisector. All right, so these two angles are the same. Now, we can also see that BD is perpendicular to AC. Okay. And finally, we can say that MF and BC are parallel. So you have two parallel lines right there. All right. So how do we prove that BM is equal to MF? So this is actually a pretty good question. If we want to prove that BM is equal to MF, well, we can try to prove a little bit of congruency right there for some triangles. Okay, and that's what we are going to do. So first of all, it also tells us that ABC is equal to 90. Okay. So if ABC is equal to 90 and MF is parallel to BC, if I'm drawing an extension from MF, you can say that this point is G, and then you're going to get another right angle there. Okay, so we can just start with extend FM to intersect AB at point G. All right, and after that, because we want to prove that BM is equal to MF, right? So we are just going to take a look at these two triangles, okay? So we have in triangle MBG and triangle MFD. First of all, we have angle MGB is equal to angle MDF. That's equal to 90 degrees, right? Because we have two right angles there. And then we have angle GMB equals angle DMF, because they are vertically opposite angles. Now we have two angles being the same. I just need another side or a corresponding side to be equal. And we can have MG equals to MD. And why is that? That's because AM is the angle bisector of GAD, angle GAD. And the property of an angle bisector is that any point on the angle bisector is equidistant to the two sides. All right, so now I have an angle, two angles, and a side being the same. It's like angle, side, angle, right? So it's going to be an ASA proof. So you can see that triangle MBG is congruent to triangle MFD, and that's going to be ASA. All right, so we have MB equals to MF, or you can say BM equals to MF, because they are the corresponding sides of congruent triangles. Okay, so that's how we can solve the last problem.